Hi everyone, this video is an exercise 11 in question 1, and in this video I'm going to do part A. So in part A we want to integrate x times 1 plus x dx. Now this section is all about integrating by substitution. So if you look at this integral, and the first thing might be that why can't just we write 1 plus x in the form x to the power of half and then expand the bracket and then continue as normal. But there's a big problem with that, because here the power is a fraction, so we cannot really expand this in the normal way that we do when the power is just a whole number. So that's why we cannot use the expansion here. And then the other method might be the reverse chain rule, but that one is not going to work either, because the problem is that the power of the bracket is not higher than this, because if we say, okay, let's say the answer is 1 plus x to the power of 3 over 2, then the problem is that when we differentiate, then we'll have 3 over 2 and then 1 plus x to the power of half. So we cannot get this x term. That's the problem. So instead of using all of these methods, in this case we need to use the use substitution method, and this is in fact one of the most, if not the most powerful integration techniques. So this is something that you will be either given the substitution in the exam and you just use the substitution to integrate, or maybe more often you will not be given the substitution and you need to figure that out yourself, which you will be eventually able to do that by practice. So in this case we are given that use this substitution to integrate. Okay, so for the first step we just substitute, whenever we see 1 plus x we substitute u. So also remember that the substitution is u is equal to 1 plus x. So instead of this term with a square root, we simply write square root of u, because 1 plus x is equal to u. But what about x? So it's actually very simple, because if we rearrange x and make x a subject, then we'll get x is equal to u minus 1. So here we'll simply have u minus 1. And also, what about here? Do we write dx? Because here the variable is now u, so we can no longer write dx. So what do we do instead? So what we do is that it's not that we cannot just write du like this, because we need to do something else. We need to take the substitution into account. So what we do is that we just take the substitution here, so u is equal to 1 plus x, and we differentiate that with respect to x. So in this case the derivative is simply equal to 1. Now we rearrange this and make the x the subject, so we'll have dx is equal to du. Now in this specific example, so we simply just, because dx is equal to du, that means we simply write du here. But there are many cases that we'll get some additional terms that, let's say it might be u times du, which you will see later, so I don't want to confuse you. Okay, so this is the setup. Now the difference, the main difference of use substitution with other methods is that you have the first method is basically like the setup. It's not the integration part. So now that the setup is almost done, we can now integrate this. So first, let's rewrite root u in the form u to the power half, and now we are ready. So we just expand the bracket, we'll get u to the power of 3 over 2 minus u to the power of half du, and now we just add 1 to the power, so 1 plus 3 over 2 is 5 over 2, so we divide by that, which becomes essentially 2 over 5 u to the power of 5 over 2, and then here we add 1, which becomes 3 over 2, but we divide by that, which becomes minus 2 over 3 u to the power of 3 over 2 plus c. Okay, we are almost done, but just remember that at the end we need to substitute back and make this in terms of x. So u is equal to 1 plus x, so we just substitute that into u. So we'll have 2 over 5 times 1 plus x to the power of 5 over 2 minus 2 over 3 times 1 plus x to the power of 3 over 2 plus c. And that's it. So that's integration by substitution.